Okay, today we're going to quickly go over the answers to using the law of sines. So let's get started. All right, so first I have a 67-degree angle and the opposite side is 22, and I have a 78-degree angle and the opposite side is x. So I have one unknown and I have three things that I know. Because I'm looking for an angle or for side length, I'm going to put the side lengths in the numerator. So I have x over the sine of 78 degrees is equal to 22 over the sine of 67 degrees. So remember, this is the law of cosines, it's looking at the ratio of a side length to the sine of the opposite angle. Okay, so in order to solve for x, I need to isolate it. So I'm going to multiply both sides of the equation by the sine of 78 degrees. So x is equal to 22 times the sine of 78 degrees divided by the sine of 67 degrees. And you'll notice sometimes I do forget to write the degree symbol. Okay, so then I go to my calculator and I'm going to type this in because I am told to find this to the nearest tenth. So it's 22 sine 78. Now notice when I type the sine, that first parenthesis came in, so I need to make sure I close the parenthesis before I start dividing. So 22 times the sine of 78 degrees divided by the sine of 67 degrees. And this is equal to approximately 23.4. It is approximately because we are rounding the number, and it's 23.4 because the 7 in the hundredths place rounds the 3 in the tenths place up. Question number 2. Again, I have x is across from the 126-degree angle. 33 degrees, while it could be a little bit difficult to see in an obtuse angle, it is the angle across from the side that has a length of 8. Again, because x is my unknown, I want that in the numerator. So this means that x over the sine of 126 degrees is equal to 8 over the sine of 33 degrees. And again, I do this because I have less steps in solving for x. Now I just have to multiply both sides of the equation by the sine of 126 degrees. So x is equal to 8 times the sine of 126 degrees divided by the sine of 33 degrees. Type that in my calculator, 8 sine 126, close the parenthesis, divide the sine of 33. So in this case, x is approximately 11.9, whatever our units are. We go on to number 3. I have that 39 degrees is across from this side labeled x, and 83 degrees is across from the side labeled 14. So x over the sine of 39 degrees is equal to 14 over the sine of 83 degrees. So x equals 14 times the sine of 39 degrees divided by the sine of 83 degrees. And again, before I started, I did forget to remind you, make sure that your calculator is in degree mode. If it's not in degree mode, you're not going to get the right answers. So I have 14 times the sine of 39 degrees, close my parentheses, divide the sine of 83 degrees. So x is approximately 8.9, whatever the units are. Again, that's 7 in the hundredths place, rounds the 8 in the tenths place up to a 9. Number 4, I have 45, a side length, which is directly across from the 87-degree angle. I have a 64-degree angle, but x, my unknown, is between the 64-degree angle and the 87-degree angle. In other words, it's across the triangle from the angle I don't have a measure for. So the first thing I have to do is find the measure of that angle. Well, that's easy enough to do because remember that the sum of the interior angles of any triangle is equal to 180 degrees. So the angle I need is going to be found by subtracting from 180. So I have 180 minus the sum of 64 and 87. So this is what I want to type in my calculator. 180 minus the sum of 64 and 87. And remember, because I keep saying the sum, that's why the 64 and 87 have to be grouped in parentheses and I'm adding. Of course, you could just simply distribute that negative and do 180 minus 64 minus 87. All right, so this angle then that I'm looking for, this angle is 29 degrees. That's the angle across from x. So that means that my equation to solve for x is x divided by the sine of 29 degrees is equal to 45 divided by the sine of 87 degrees. Right? And so now I'm going to multiply both sides times the sine of 29 degrees. So x is equal to 45 times the sine of 29 degrees divided by the sine of 87 degrees. So 45 sine 29, close the parentheses, divide sine 87. So x is approximately 21.9, whatever my units are. Number 5 looks like the same situation in number 5. I'm given two angles. I'm given the angle in between the two angles. Sorry, I'm given the side length in between the two angles, right? But I don't have the angle across from that 32 degree or the 32 length side. So I need to find that first. So remember again, that's 180 minus the sum of the other two angles. So 180 minus the sum of 42 and 105. So this angle that I'm looking for here, this angle is 33 degrees. So that tells me that x over the sine of 105 degrees is equal to 32 over the sine of 33 degrees. Right? So I'm going to multiply both sides times the sine of 105. So x is equal to 32 times the sine of 105 degrees divided by the sine of 33 degrees. Close the parentheses. So x is approximately 56.8 units. All right, looking at number 6, same situation. So 180 minus the sum of 51 and 65. Oh, now notice I forgot to put that parenthesis in, so I have two options. Here I can just go back and make sure that I've distributed the negative, right? That will work as well. So this angle is 64 degrees, and you could check that. 64 plus 65 plus 51 is 180. Okay, so I can write my equation now. So x divided by the sine of 64 degrees is equal to 27 divided by the sine of 51 degrees. So x equals 27 times the sine of 64 degrees divided by the sine of 51 degrees. So 27 sine 64, close my parentheses, divide sine 51. So x is approximately 31.2, whatever my units are. Okay, so this is what we do when we're looking for a side length. In the next video, we'll talk about what to do when we're looking for an angle measure.